Hello everyone, this is the question that you think's quite difficult for you before. So we would like to explain step by step how we answer this question. First of all, we have to analyze the data first, right? So in here, a beaker contains a liquid of the mass 120 gram. So this is actually the mass of the liquid only. I will give the symbol ml. And then the liquid is supplied with the thermal energy at the rate of 810 watt. This is the thermal energy rate transfer, which is power. And you can see also the unit here is watt. So this one is power. Then what is the next one? We have a beaker and the mass of the beaker is 42 grams. So this is actually mass of the beaker. And the specific heat capacity, which is C, and this is actually C of the beaker because it's still talking about the beaker. Please be attention because what happened in here, it's joule per gram per Kelvin. That means the mass must be gram. You don't have to change the mass. And also the unit here must be Kelvin for delta temperature. The beaker and the liquid are in the thermal equilibrium. So, in the beginning or until the end, let's see, with each other at all time. That means what happened from the beginning until the end, the temperature of the liquid and the temperature of the beaker, if the liquid changes, the beaker also will change the change. Then in here we can say delta temperature of the beaker will be the same as delta temperature of the liquid. And then what happened? Insulated. Both of them insulated from the surrounding. That means no heat loss. Right. So what is going to be the next one? You see this one, right? So we have the two line. This is the first line, which is diagonal, and the second line is the horizontal. Since we are talking about the specific heat capacity, that's supposed to be about changing temperature. So which one that we will have to use? This one only. But actually we need it for the first question. State the boiling temperature in degrees Celsius of the liquid. Boiling means change of the state. Change of the state must be horizontal. So this is the second line. Then you have to just go to the left and then look at the temperature. Temperature here is actually 80. Yeah, reading the scale, it's going to be your basic competence. So you really have to do it. And in here you can see it's degrees Celsius the unit. And then you have to find it in a unit, right? No need to convert. So just write 80. Okay, now what is it? You have to determine the specific heat capacity of the liquid, which is the Cl. And pay attention to the final unit. The mass must be in the gram. Before the mass of the beaker, the mass of the liquid also in gram. No need to convert. And the change of temperature must be in Kelvin. And if you pay attention, this is the same unit as the specific heat capacity of the beaker. So Cb and the Cl will have the same unit. Now, what should we do? First of all, we have a beaker here. Okay, sorry, let's say it's a beaker. And you put the water here. And it's insulated, so we cover it with insulation. Then what happened? We heat both of them. It say delta temperature of the beaker will be the same with delta temperature of the liquid, not Kelvin, liquid. Then which one that we have to use? The first graph or the first line. So the temperature initially from 25 degrees Celsius and the final temperature is 80 degrees Celsius. Then you will get the delta T, which is 80 minus 55, which is, what is that? It is, 80 minus 25, which is 55 degrees Celsius. But don't forget what happened. We have to use Kelvin because in here Kelvin, in here also Kelvin. Remember I said before the delta temperature in Kelvin and delta temperature in Celsius will be the same. So in here the delta temperature in Kelvin will be also 55 Kelvin. Sorry for Kelvin, no degree. Then that means delta temperature of the beaker is 55 Kelvin. And delta temperature of the liquid also 55 Kelvin. Now let's go back into the diagram. What is this? So basically we give total thermal heat or total heat. This total heat, what happened? It will be used to increase the temperature of the liquid. So there will be QL. Also increase the temperature of the beaker. So there will be QB. So Q total as the input, QB, and QL is the output. So you will have this equation. Q total will be equal to QB plus QL. Do we have to add with the heat loss? No. Say again, insulated, no heat loss. Okay, after this, until this, sorry, if you think you're still confused, please go back again because it's still what we call it half of the explanation. There will be more. Then let's go. How do we know the Q total? Q total is basically the heat given by the supply with the thermal capacity at the rate blah blah blah. So that is gonna be using the power and the time. So Q total will be power times time. What is the power? 810. And what is the time? Okay, the time from the gradient from 25, this one, until 80, you can see the time is from this one to this one. This is 0, this is 21. So what is that? Yeah, so the time is 21 seconds. So 810 times 21, which is, let's run up, 17,000 and it's joule. Okay, now you have the Q total. Next, you have to find specific heat capacity of the liquid, CL. What is the equation of the specific heat capacity? CL is Q divided by M delta T. Don't forget, the M must be M of liquid, Q of the liquid, and also delta T of the liquid. Do we have the delta T of the liquid? This one. Do we have the mass of the liquid? This one. Now, we have to find the Q of the liquid from this equation. Q of the liquid must be Q total minus Q beaker. Now, we have to find the Q beaker. Remember, beaker changed the temperature. So, you can use MC delta T. What is the M? Mass of the beaker, C of the beaker, delta T of the beaker. What is the mass of the beaker? Let's go up. The mass of the beaker is 42. Again, no need to convert into gram because no need to convert into kilogram because it's in gram. And then what's the C? The C of beaker is also in the gram here. So just write it 0.84. And then the delta TB, you got it from here, 55 Kelvin. Now, guys, grab your calculator. Okay, so that means 42 times 0.84 times 55. What is it? 42 times 0.84 times 55. Okay, again, I'm gonna give you time. Yes, it's 1,900. Don't forget, this is heat, so it's joule. Okay, now we got the QB already. Let's move the QB here. Q total already 17,000, right? And the QB is 1900. And then what do you got? Use calculator again. 17,000 minus 1900, which is 15,100. It's joule because it's cube. We get the QL. Then let's submit. 15,100. The mass of the liquid, it's here, 120. And then the delta T of the liquid, okay, once more, it's here, 55. Okay, grab your calculator. This is the last calculation. Okay, what is it? Yes, it's actually 2.288. Then, how many significant figures are? Okay, remember you have to apply the significant figure rule. I'm gonna use different color. This one, how many significant figure? 3. This one, 2. This one, 2. Since this is multiplication and also division, you have to take the smallest number of the significant figure, which is 2. So that means this become 2.3, which is correct. If you compare with the Maxim, it's 2.3 joule per gram per Kelvin. So this is how you answer this question. Thank you.